All right, we're going to take a look at the rest of review part two. We're going to start with something called hydrogen bond. So how hydrogen bond works is that when we have a polar covalent bond, and the hydrogen is involved in this type of bond, sometimes you can have this interaction between different molecules called a hydrogen bond. So how it works is that, take water as an example. This is really the only example you need to know about. H2O has two hydrogens and one oxygen. Oxygen is a lot more electronegative than the hydrogen. So what happens is that the electrons that are being shared between the hydrogen and the oxygen are a lot closer to the oxygen than the hydrogen. So the end result is that because this oxygen has these electrons pulled toward it, the electrons carrying the negative charges is going to give oxygen a partial negative charge and leave hydrogen with a partial positive charge because its electrons are kind of being pushed away, right? So think about this sharing of this paper again. If oxygen, which is over here, is taking a lot more of the electrons, and the hydrogen is kind of losing its electron a little bit. It doesn't lose it completely because they're still sharing. This is still a covalent bond. So then you have this interaction, you have this polar covalent bond. However, if you were to put different water molecules, so instead of just one water molecule, you have different water molecules close to each other, then you have something called a hydrogen bond. It's an interaction between the partial positive on one water molecule and another partial negative on another water molecule. So this interaction is called a hydrogen bond. So when we look at a question, which type of bond exists between atoms within one molecule? That is your ionic bond or covalent bond. Which type of bond is an attraction force between different molecules? Then you can have hydrogen bond. So again, hydrogen bond is in between different molecules. It's not within one molecule anymore. It's this attraction force between different molecules. Which type of bond is a result of transfer of electron and of a very electronegative atom and a very non-electronegative atom? That will be an ionic bond. Sharing of electrons is a covalent bond. An equal share of electrons is called a non-polar covalent bond because there's no pole. It's an equal pole, right? And then this unequal share of electron is called a non-polar covalent bond. What did I say? Oh, I meant unequal share of electrons is called a polar covalent bond. J is kind of the same question. So the next one is called how can you have a partial positive versus a partial negative? The more electronegative atom, such as the oxygen in H2O, will have a partial negative because it's pulling the electrons closer to it. And the partial positive charge could happen to the hydrogen atom, which has electrons being pulled away from it. Electronegativity is how much an atom attracts the electrons around it. So then, as we're talking about water, we can also talk about the properties of water, which enables a lot of living organisms to be able to exist in the first place, right? So starting with number one, polarity, we say water is polar because there's this polar bond between the hydrogen and the oxygen. That is called a polar bond, which makes water a polar molecule. Water is also a very good solvent. We call water a universal solvent because water, since it has this partial positive and negative charge, it can interact with anything else that has partial positive or even full positive or negative charges. Okay, so water is what we call a universal solvent because of its polarity. Right? Really, most of these properties of water come from its polarity. Then we have something called cohesion, where basically the interactions between different water molecules, the attractions between different water molecules, these hydrogen bonds, really, those are called cohesion, water's ability to attach to itself. The other one is called adhesion, which is water attracting to another surface, right? Again, it's because of the property of the water as it being polar, right? So we have cohesion, we have adhesion, and then this whole thing, cohesion and adhesion together, cohesion and adhesion together, but mostly the cohesion part, creates something called a surface tension, right? Because we have all these water molecules lined up at the surface of a liquid, and they have these attraction forces in between each other, then it's really hard to break those bonds. Because hydrogen bonds, if you have a lot of it, it's actually a pretty strong bond, even though it's not really a bond in between atoms within the same molecule. So this is surface tension, right? If you have bugs being able to walk on water, this is because of the surface tension. It's hard to break these tensions between the water molecules. And then we have something called capillary action. A capillary tube is a very thin tube that liquid can travel upward from. So a capillary action is water being able to travel against gravity, from a lower area to a higher area. What causes that is cohesion and adhesion at the same time. So you have cohesion being able to have one water pulling another water, pulling, and then all the water can go upward at the same time. And then we have water being attracted to the side of the capillary tube. So altogether, water is able to go against gravity without any kind of force at all. And then we have water in liquid form being less dense than water in solid form. Just think about this, right? Just think about this for a second. When you go swimming in the ocean, for example, or you go swimming in general, generally where your feet are at, paddling underneath the water, you can feel your feet being kind of cold, right? Water is colder when, the colder water is more dense, which is what makes the colder water, in the lower area, and water that are warmer are on the surface. That's normal. Normally, when molecules are, let's take a look at this picture right here. Right, when molecules are at low temperature, the molecules move slower, and they're less far apart from each other, so making it less dense, or making it more dense, so you'll go to the bottom of this liquid. And then we have high specific heat. Oh no, what am I talking about? And then you have molecules moving faster, so they're farther apart from each other. That's what makes warmer water less dense, which makes warmer water be on the top of the water. Okay, this is pretty normal for all the molecules, but here's what's not normal. When you have ice, which is even colder than just cold water, ice is actually less dense than liquid water. So this solid form of water is actually less dense than the liquid form of water, which is very not normal for a lot of molecules in the world. So here's what happens. When water molecules are just in liquid form, they can just float around like this, right? It could be pretty disordered. When water molecules are warmer, or even if it's a gas, they're farther apart, it's less dense. This is normal. But when water gets even colder, normally the molecules should be closer together. However, because of the interactions between the positively charged, partial positively charged hydrogen on water and the partial negatively charged oxygen on water, this attraction force, this hydrogen bond, makes the water molecule align in a way that it has to align in this crystalline form. There has to be a certain space between the oxygen and the hydrogen. As a result, water molecule, once it becomes solid, once it becomes ice, it is actually less dense, which is what makes ice float on water, which is great because then fish can still survive over the winter, right? The last thing about water is called high specific heat. High specific heat means it's hard, where it takes a lot of heat to increase the temperature of water, and it takes and when water when water temperature lowers, it releases a lot of heat as well. So here's how this works. Think about molecules movement, right? If we're heating up water, we need the water molecules moving faster. And as the water molecules are moving faster, you have to break the hydrogen bonds. It's difficult to break those hydrogen bonds, which means it's difficult to have the water molecules moving faster, which means it's hard for water to raise its temperature. So it takes a lot of energy to heat up water. If you look at this picture right here, that means water has high specific heat. Here's all that we have for review part 2.